Okay, welcome back to hypothesis testing. In this video, I'll be looking at questions 6 through 9. In question 6, a customer has complained to the bike sharing company that their trip was recorded incorrectly. The trip ID is 724828, and the customer says that their rental started at Terminal 70, but the record says that it started at a different station. So what we're going to try to do is figure out the starting terminal for this trip in our records. And here's a good time for you to pause the video and try this on your own. Okay, if you're looking for a hint, one thing that you could try is using the where command. So we could use the trip table, and we could filter it using the where command to try to understand only the row that has this trip ID. Try that now. Okay, so how are we going to filter this table? Well, we'll try to get the trip ID to be r dot equal to this integer, 72, 48, 28. This is a pretty long process to run such a thing, but we can do it, and then we can print it out. One thing you might try doing is just running it. There it is. It looks like the start terminal is 64. So let's write a little statement to that effect. Print the start terminal in our records is terminal 64. Great. Now we want to set up a hypothesis test to determine if there's evidence for the customer's claim. We will try to prove that the trip did not start at Terminal 70. So the alternative hypothesis here is that the trip did not start at Terminal 70. And the question is, what's the null hypothesis? The null hypothesis is the opposite of the alternative hypothesis. So the trip did start at Terminal 70. And always the null hypothesis is set up in such a way that that we're able to simulate under the null hypothesis assumptions. So that almost always says that some numbers could have been drawn from a particular distribution that we know about. In this case, terminal 70's times where they of rental starting at Terminal 70. Okay, so let's look at question 8. Under the assumptions of the null hypothesis, we could gather evidence about reasonable values of the duration for the customer's trip. And in fact, we've already done that in the previous video. We used this information to draw a histogram. Let's use the duration of the trip as the test statistic. And we'll reject the null hypothesis if the duration is too low. Well, let's have another look at at question 6 and see what's the duration. It was 655. So maybe the first thing to do here is to write down test stat equals 655. That gives us some idea of how long the customer's trip took. And we're going to use the bootstrap data on our durations from Terminal 70 to determine the p-value for the observed test statistic. In this case, we want to determine what proportion of the test statistics that we looked at in making up this bootstrap table. We have 500 test statistics here, and some of them are as low as 655. These ones over here on the left, and we'd like to know how many of them really are below 655 or at or below 655. So let's call that that's called the p-value, or sometimes called the empirical p-value, and it's the proportion of such trips. So let's try to figure out by looking at array of 500 how many of those are less than or equal to the test statistic, 655, that will be an array of zeros and ones, and we'll use the np count non-zero function to count up how many of these are ones, that is how many times of the 500 simulated test statistics were they actually below the observed test statistic, and then we'll divide by the 500 to get a proportion. And oops, that's helpful, but what we really want is to see also the empirical p-value. And the empirical p-value is 0.016, 1.6%. And now the question is, do you reject or fail to reject the null hypothesis at the 1% cutoff level? All right, think about that for a moment, and then I'll give you the answer. All right, we always have to compare the empirical p-value against the cutoff level. And when the empirical p-value is lower than the cutoff level, that means that, that the data is so extreme that we should reject the null hypothesis in favor of the alternative hypothesis. And here at 1.6%, it's not below the 1% cutoff level. So that means that we fail to reject the null hypothesis. So here we fail to reject the null hypothesis. Oops. Hypothesis, since the empirical p-value is higher than the cutoff level. This means that the evidence favors the null hypothesis in this case, favors and the null hypothesis is that the trip did start at terminal 70, favors the hypothesis that the trip did start at terminal 70. And in this case, it means that the customer seems to be correct. The customer seems to be correct, and or at least we don't have sufficient evidence to prove that they're wrong, to conclude, let's say, rather than prove, to conclude that the customer is wrong. And so the company should alter their records, let's say. Of course, when you alter records like that, you might want to put some kind of note down saying that we've altered our record because this empirical p-value is larger than the 1% cutoff level, and so we couldn't find sufficient evidence to show that the customer was wrong. On the other hand, somebody else then could come back later and look at the evidence again with a different cutoff level pertaining to their own sense of risk and the value of the decision, etc. And they might come to a slightly different conclusion than the company. So we would want to preserve the historical record here, and in general, you want to preserve documents and indicate why you changed them in order to facilitate later use and later review of these records. All right, this is a good place to stop. In the next short video, I'll talk about design of experiments in question 10.